Okay, my friends, this should be fun. I have been talking about this hair follicle and this attachment to the muscle, the erector pili muscle, attaches right here. That makes your hair stand up on end. This little bulbous looking stuff here is from the sebaceous gland. That oils up the hair follicle that comes up the shaft, and this is the hair follicle at the bud at the bottom, and those two little dots right there, if you can see those, are the artery and the vein. So I claim virtually every time you have a membrane, you're going to have catalase in there. You should be able to pick up catalase unless this is just so transitioned there is no catalase left. But I believe there will be. And I believe there will be where the membranes attach down here to hold that muscle in. Because it has to be separated. You have to have membranes. And they usually, when they go down inside something, you can put the hydrogen peroxide on there, and it'll get down in there, and it should foam right up. Now, usually they get really white foamy. This may not do it at all, because this thing is completely transitioned. Usually, let me show you one here. Sometimes they'll be like this. Sometimes they'll be that perfect. The color and everything is still there, and it has all of the texture, the meat and everything. But it's a stone. Has the fascia on there and everything. Now, will that foam up? I think it might. I'm gonna put it in a microscope now and see if it does. Who knows? Maybe it will. Maybe it won't. This is all about discovery, my friends. Okay, that's the hair right there in the microscope. Now here it is up in the screen. Now we're quite a ways off from it, and I'm going to get much closer. However, what you're seeing right now is the erector pili muscle attachment, and that's the core of it. I believe this is where the vein side came, and I believe that's where the artery side fed down, because everything has to have blood vessels going in and out of everywhere. Now I believe we should see a really good foaming action here. It looks to me like it still has some good biology, and over here as well, and maybe everywhere, because there's a ton of little wrappings of if you really look at it and know how to look, and you'll probably see it once I put the stuff on, but see, these are all different layers of muscle. And when you look at the actual anatomical, you can see that's exactly what happens, is they're all like wrapped around in circle after circle after, like an eggshells, one after the other. All right, like I said before, I am way off of this thing, so you might not see any foaming coming out, but I will get right down close. Now I'm putting on hydrogen peroxide right now, and hydrogen peroxide has that extreme extra oxygen. It's H2O2 instead of H2O. All right, now let's see if we can see any foaming from this high up. And I really do not yet. But again, we're quite a ways off. These are tiny little bubbles, and this thing is highly transitioned. So this may either take a few minutes or a minute or two, or it may not do anything. It's always a mystery to me. All right, here we go. I come right down on top of it. Boom. And let's see if we can see anything now. Yep, see it? That's the membranes right there. Let me turn the lights down a little bit, you see it. You see that foamy stuff? That's actually from a membrane and having catalase interacting with the hydrogen peroxide that's trying to invade. Let me move this around and see if I can find a better one. Watch that stuff. You see it fuzzy? That's the membrane. So this thing still has catalase inside of it. Here's some more. See there? Wherever you see it bubbling up, that's where catalase is attacking. The rest, you don't see it bubbling. It doesn't bubble unless it's got catalase to break off that extra oxygen. You see it bubbling over here? And so there's no question this thing is biological, and there's no question it's a gigantic hair follicle. It's just the way life is. So it's got to start to come around and deal with the reality of our ancient past. This is not deniable. And as far as I'm concerned, there could be remnants of DNA in there. I had my stuff tested for DNA, and it said it was excellent quality. Now, I don't know if that means complete, but it was basically like raw red blood when I took it out. But it was dried, that's all. It's like a scat. Okay, this is the simple quickie. This is a bacteria. It has these little ribosomes, which are the packages of chemistry, which are called the enzymes. Now, these live in this layer, which is called the fluid-filled highway in these membranes. And they're now talking about it being basically something called interstitium, which is seen right here. These fluid-filled highways that run all through your body, everywhere. And they protect you from this layer invading this layer or this layer invading that layer. Now, if something breaks down through these walls of your skin and so forth, and these tissue membranes, and it'll come deeper and deeper and deeper, this is supposed to fight back and kill it. And here's what it looks like in an artist's rendition. All right, this is cancer. And what happens is you start to nibble away at the tissue layer that surrounds an organ, let's say. This layer here surrounds that organ. Right? It's supposed to keep the contents sequestered, keep it away from everything else. Nothing can invade it. But it has to have some good stuff come in, and the bad stuff has to be able to get out. So they have these certain little protein channels, what they call them. So things can get in and out that are supposed to, but nothing else. Well, this guy here says, I want to get down and eat some of this good stuff way down here, because this is where your good tissue is, down here. So it tries to get down, 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 and if nobody stops it, it just keeps going and it grows right down there. You get cancer just like that. Well, what stops it? Basically, all of these things here have different little chemistry in them, all your cells of your skin and so forth. They don't normally get invaded unless you get cut and gouged and you get way down in here. Now, some people can't stop though. Some of these things just, they don't have the chemistry. They don't have the bacteria. They don't have the enzymes. So they get down, and when they hit this layer here, then you got where you're into your fluid-filled highway. And if they get through that, then you got real problems. So don't forget, this has just been discovered. It's just brand new discovery, 2018. Meet your interstitium, a newfound organ. This is the fluid-filled highway. This I discovered in my Mudfossil research, which I think I just showed you, foaming of these gigantic creatures in the membranes. And I could see them because these creatures are just gigantic. So I could actually see these layers, and I questioned anatomists and everybody, and finally we resolved it, that it is this fluid-filled highway. And this is where all these bacteria reside. And they zip, 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 zip through the body. And now they're just realizing this, and now they're starting to look for bacteria and proteins that we need a database. And let's just cut to the chase. We need a database of what proteins, actually what bacteria are in each person's body. Now, this is a little bit tricky because the bacteria are going to have different bacteria in different areas of the body, but there should be some profile somehow that we can get that fits the body's total bacterial colonies. Somehow, I'm not sure. This is something tricky. You might have to have some really top-end biologists and so forth figure out how to extract these samples from specific places, or can we just get them from the feces? I don't know, because a fecal matter transplant appears to work very, very well at repopulating virtually all the bacteria in your body. So does it always show up in the feces? I don't know. But I would start with that and see if we can get a database from just the feces. All right, from everybody. That's a simple thing to harvest. It's not a big deal. And then somehow get a profile of that. Then we move on from there. What else can we find out? What about the urinary tract? What about specific organs? What about sweat glands under your armpits, or the anal canal, or all kinds of places? What I'm saying, this is just new stuff, and I'm telling you, in the medical industry, everything is just glacial. And now the glaciers are moving faster than medicine. I'm telling you, glaciers are in trouble. Medicine's in deeper trouble. They just can't get out of their, they're afraid to get sued. They don't want to step outside their boundaries. They don't want to make claims that, can come back to haunt them. I understand that. This is research, and this was fought against hard. But it's here, and there's no stopping it now. This is the fluid-filled highway that has to have your correct bacteria in there. So let's take a little deeper look at the bacteria. And what does it do? What does it create? What's an enzyme? What's a protein? What do they look like? See, this is a global threat, worldwide global threat, the war against superbugs. Superbugs should not invade you if you are fully protected, I think. I'm not certain of that, but if the walls of your intestines and your interstitium is not perfectly coated with the correct bacteria, you're invadable. That's called a pre-existing condition. So now if a superbug gets inside of you, just like that one that we were just talking about, I think we were just talking about it, one cell can wipe you out, kill you. All right, don't forget, disease is invasion. Membranes are supposed to keep this stuff out and keep this stuff in. The invasive route is through here. If you don't have the right enzymes to counteract the invaders, you are invadable, and that's how you get disease. Invasion. And this is that layer. This is where the fluid-filled highway is, where these guys scoot around, and this is the skin. It can get cut and so forth. It happens all day long. And stuff is in here, and bacteria and all kind of nasty, nasty stuff. But it gets over there, you're in trouble. All right. It appears to me that the immune cell layer here is the housing units for the bacteria. And they live in here, basically, and they produce enzymes and so forth. All right, and they can jump right into the fluid-filled highway anytime they want. If somebody calls them and says, hey, we need some help, out they go. So now what does a bacteria look like? What does it do? How does it function? How big is it? Well, these things are like a single cell. They're like a single cell. One cell, that's it. And inside of it, it has DNA just like we do, but its DNA says, I am going to make this type of a ribosome all day long. That's all I'm going to do. That's my life, is to make this. And when it makes that ribosome, that sucker is so precise and so complicated, it's unbelievable. Now, they have a flagellum, most of them, and they go flying down that fluid-filled highway. All right, so that's all. This is the most important thing, because without this, you don't get the ribosome. You don't have the ribosome, you don't have the chemistry, you don't have the enzymes. Let me show you what happens when that ribosome hits the real world. All right, this is a bacterial infection, and these are the ribosomes that are going to unleash the enzymes to kill these things, so they don't break through the good tissue, the fascia. All right, so this is like bacterial type infection. You get all these little buggers trying to attack. Then you have the tumor type infections, and they're attacked as the same way. We try to attack them, but the tumor is growing, and its tentacles are inside, and it's growing into a tumor. So this isn't like a virus. This is a tumor. But the other ones, the viruses, make you sick in a number of other ways, and they just degrade you, basically. That's how I see them. I could be wrong. All right, so you saw the bacteria, very simplistic. Now let's see, what does the bacteria do? This is what it does. All right, that's the bacteria. All right, it has DNA inside of it, like I showed you before, and the DNA is the program that says, I am going to make a ribosome, which is here. All of this, you don't need to know about this, but it's made of polypeptide chains, which are protein chains. They're the amino acids. And they sequence them together in just a certain way to hook in with your DNA and say, I'm immune from whatever it is. These are the things that create the chemistry in your body to create the enzymes and so forth. Your body doesn't just create them all by itself. The mechanisms there, all right, the chemistry is only made by these programs. So somebody has to come up and program a thing. You're not just squirting out all this stuff all day long in huge quantities. You're going to have huge quantities if you're getting invaded, yes. And the body knows how to do that. And this is pretty deep stuff. But I'm going to tell you right now, there's billions probably of different configurations. There's 20 different amino acids. And they can be configured into chains that are just astronomically long. And here's, I think I got another shot somewhere. Well, here's what happens. Let's simplify things. These are those balls that come out. They are the ribosomes. They're in what they call a capsid, and that is a sheath pops open when it gets to its destination. And what comes out? Either an enzyme or a protein. What is the difference? Well, an enzyme is something that goes and it breaks molecules down very, very, very fast. It's a catalyst. It destroys things. It breaks it down in components. A protein is just the opposite. Protein builds things up. So that one here is a destroyer. This one here is a builder. This breaks down the food into those little bits and pieces so that you can digest it. It breaks down dead cells in your body and everything, because all the trash got to get cleaned up. You got to break down the food before you can ingest it, but you also have to build your muscles and your tendons and your eyeballs and your fingernails and everything else. And that's what this does. But they come from the same source, from bacteria. You see that? That's what an enzyme looks like. And every one of these little dots on the end of all these things, that gives it its magnetic signature, just like this. Just like this. And if it doesn't come out this exact, identical, every single one of these touching the same spots on the same molecules, it doesn't work. This is its signature, its molecular signature, its magnetic signature. And when the enzymes squirt these things out, they squirt them out in chains. And then the chains get reattached according to the messenger RNA, and then they get transcribed and so forth. You can look into all that stuff, but it's a little it's actually not that complicated. I'm not kidding you. This stuff is not. Look at this. This is all it is. That's the ribosome I'm talking about, squirting out. Well, how does it get programmed? These amino acids are floating around all in you. There's like 20 of them. and then it turns into a chain, and the chain runs through here, and it decides what do we want to use, what we don't want to use, and it programs a ribosome using the messenger RNA. So it's not that hard. You know, you got to dig around a little bit and think a little, but it's not that hard. And this is all the different shapes and sizes or arrangements of bacterial, bacteria. Now, this is really important. People just glaze that over. Oh yeah, that's a rod-like one. That's all kind of different spirochetes and all this stuff. Well, they can only attach a certain way to certain things if they have these certain shapes. All right, there's a yin and a yang to everything. So one is one way and one is another way. This is not going to work with something that works with this. Now, I don't know if that's important or not. It's kind of interesting to see that there's so many different shapes, and there's. But anyway, I think that pretty much covers what I want to tell you. But anyway, here's cancer of this is bone cancer. And what happened was the fascia, the coating, that fascia that has that membrane, it says you stay out and you stay in. Well, something happened. And this got out, and the other stuff, it turned into all crystals, crystallizing in that layer. All right, and that will happen. I think these are called oxalates, which are crystals.